That works. Okay, what questions on the shark bite do we want to see? Do go over, show me on your hands. One. I see some fives. And three. So we'll do 1, 5, and 3. We're doing 1, 5, and 3. So starting with number 1, simplify. We're going to start to distribute to 10x minus 14 plus 3x. And then combine like terms like we would if we were solving. So 13x minus 14. But after that, there's nothing else left to do. We can't do anything with it. There's no equals. I'm not solving, so that's it. Questions on that? Number 3, we're solving the equation for x. So to get x out of the denominator, I'm going to multiply it on both sides. And then to get x by itself, I'm going to divide both sides by y. So that x equals k over y. Questions on that one? Which one? K, yes. Sorry, it doesn't look like it, but it's supposed to be a K. Okay, Chloe, can you pose your question? No, if we weren't already going over 3 of them, then I would have said yes, but. For number 5, the x and y intercepts, they happen to fall at the same place at 0, 0. So you should have both of those for x and for y. Okay, you got a new shark bite answer sheet. I put it on color paper so that you don't lose it. Hold on to this so that the next time you do a shark bite or the next 4 times you have this and can print it in. Okay, and then Kenny, I need you back again. Look at the notes. So last class we did a lot of practice for multi-step inequalities to help us prepare for today. So I'm going to have you write this down. And everyone that has an iPad or a computer open, go ahead and close that. So today we're going to talk about compound inequalities, which is two or more inequalities joined together with the words and or the word or. So we're going to start off with or inequalities. And or inequalities have a tendency to graph apart, so away from each other. Anyone else will need this hard? So I'm going to show you how to graph it first, and then we'll dive into the solving piece. So if I'm graphing this, let's say I solved it, I got this as my answer, x is less than or equal to -2, or x is greater than 3. I'm going to graph them both on the same line. So one is going to be, would this be closed or open? Closed at -2. Going to the left, everything less than or equal to. Then the other one would be open at 3, going to the right. So when you graph these, they're going to look like that. And then remember, the interval notation is really for practice. You'll see it on Delta Math, but you won't see it on the quiz and test. But it is good practice for when we actually do it later. So interval notation, if I'm looking at this, the furthest point to the left, where does this keep going? But negative infinity. Then it stops at -2, which would be a square bracket. Then you can write the word or you might see this U. Means union, like this part and this part together. Then this starts at 3, which is parentheses, and it ends at, where would that end if I kept going to the right? Okay, so that's what that inequality, the interval notation is going to look like. The inequality notation would look like this, but the interval notation would look like this. Okay, now let's get into some of this. For this, you're going to solve these separately. You're going to do this and the other one separately. What you do to one, you don't do to the other. So how would I solve the one on the left? How would I get x by itself? Add 4 to both sides. So we have x is less than -3. And now that's by itself, so we're done with that one. What about the other one? How would I get that one by itself? Divide by 2. So x is greater than or equal to 6. And then I would put an or in between. So we've solved the or inequality. Now we can graph it. That would be open at -3, going to the left, close at 6, going to the right. If it's closed, it's gonna have an equal to sign, the line underneath. So this one doesn't, but this one does. And then the interval notation is gonna look similar. It's gonna start at -infinity. Gonna stop at -3, but this is gonna be a parenthesis because it's open. Or the U, you can put either or. Starting again at 6, square bracket, and ending at infinity. Do you have any questions on how we solve that? And jump down to number 3. How would I solve the equation on the left for number 3? Not for number 2, for number 3. Sorry, I skipped. -9. We have 2x is greater than 8. And then by 2, it's good. So x is greater than 4. Then the process is going to be similar for the one on the right, but subtract 10. So 5x is less than 0, it's okay that we got a 0. Divide so that x is less than 0. Now, these are not less than first and greater than first. That's okay. If you want to change that order, that's also fine. You just have to make sure you graph it correct. So this one would start at 4, would be open and would go to the right. The other one would start at 0, would be open and would go to the left. And then that interval notation, start at negative infinity, stop at 0, parentheses, or for the u, start again at 4, and end at infinity. Any questions on that one? Let's do one more or before we move on to and. Let's do number 5. So in number 5, what would be our first step? Distribute the -3 for the one on the left. We have -6x minus 3 is less than -15. And then I have 3 on both sides. And when I divide both sides by -6, what happens? The sign changes direction. Flip the sign. And it becomes positive. How would we get x by itself for the second one? How would we get x by itself here? How would we start that one? Subtract 1. Negative x is greater than or equal to 4. And then divide both sides by -1 because there's that invisible 1 in front of the x. The sign is again going to change directions. And that'll be a negative. So again, it's backwards, but as long as I graph it right, it'll be fine. So the first one, x is greater than 2. So open at 2, going to the right. And then close at -4, going to the left. And that interval notation, start at negative infinity, end at -4, square bracket, or the u, start again at 2, end at infinity. Again, I'm not stressing too much if the parentheses, all of that isn't making too much sense. Yes, you'll see it in Delta Math, but you won't see it on the quiz and test, so it's okay. And you can use your notes on Delta Math. Any questions in general on the or inequalities before we do and? Go on to the next page. Everything we just learned about or is going to be completely different for and. So while or, sorry, let me back that for a second because I forgot to say this. On Delta Math, most of the ones you see on Delta Math will do exactly what we did, graph opposite, like these. There, you might have some that overlap, but it's looking for the entirety, reading it left to right, what is the whole inequality or the whole interval notation. So if you get one like that and you help, let us know. Okay, and then in general, and inequalities have a tendency to graph together instead of apart. That would look like this. If I start to graph this, x is greater than or equal to -6 would be closed at -6, going to the right. X is less than or equal to 1 would be closed at 1, going to the left. And here they overlap. So I'm looking for the and, where they overlap. So yes, you could do both of these if you want, or you could just draw where they overlap. So starting at -6, ending at 1, and drawing a line in between. Questions on that before I do the interval notation? That's definitely great. Thank you. So for the interval notation, I'm just looking for where do they overlap. I'm not looking at, yes, this keeps going left and right towards infinities, both negative and positive, but I'm just looking for this part. So that would be from start to finish, starting at -6, ending at 1. And they're both closed, so they're both square brackets. So no infinities in this. Okay, and then sometimes you'll see it written like this, but for the quiz, for the test, I want you to write it in a condensed format. So if I took this and wrote it here, x is greater than or equal to -6 and x is less than or equal to 1. Instead of writing both of them separately, I'm going to write it as a condensed format where I'm taking the lowest number, -6, and then whatever sign goes with it, but it will always be a less than or a less than or equal to, just because that's how the format goes. Then x, then the other sign, then the highest number. So instead of 2 inequalities, I have 1 condensed. Okay, and then I'm going to show you how to solve it with the condensed format and how you could separate it if that makes it easier for you. So in this, because everything is condensed, what I do to one piece, I'm doing to everything. So treat this like one big inequality. If I were to get this x in the middle by itself, what would I do to 4? How could I get rid of that 4? So I'm going to do that to everything in the middle and on the outsides. So that this becomes -2 is less than or equal to x, which is less than 5. It's already in condensed form, so I don't need to change anything. If I were to graph it like this, I would start at -2, and that would be closed. Go to 5, and that would be open, and draw a line in between. And that would show me this is where they overlap. And that interval notation would be from start to finish, starting at -2, square bracket, ending at 5, sorry. So if that makes sense, do that. If you would rather see them separated, you can do what I'm about to do. But if it made sense, ignore this. If you would like, you could separate it by covering up one piece of it. Just looking at the first part, 2 is less than or equal to x plus 4. Solving just that piece by subtracting still. And then taking just the second half, so covering up the 2 less than, and have x plus 4 is less than 9. And just solving this piece by subtracting. Then you would have your 2 inequalities like we had here. If you wanted to graph them separately to see where they overlap, you could do that. This one would be the same, x is less than 5. But this one you have to either read backwards or flip the whole thing around. X is greater than or equal to -2. So you can see that overlap. And then draw where they overlap. Again, the separation piece and drawing these two, the arrow with the arrows is not a necessity. But if that helps you see it, you can do it that way. But at the end, you still need this condensed answer. And this condensed graph. Yes.
You not changing that.
It will already be in this format, so you can just keep it there. But if you want to do this, you have to know how to put it back here, yes. The condensed form, correct, and the condensed overlap, yep. Okay. Let's do another one, let's do number 8. How would I start number 8? Correct. And number 8, I'm sorry, you were on 2. Add 4, yes. -12 is less than or equal to 3x, which is less than or equal to 6. And then our last step, divide everything by 3. -4 is less than or equal to x, which is less than or equal to 2. Again, it's already in condensed form. I'm not going to do the separating this time. I'm going to start at -4. That's going to be closed. End at 2. That's also going to be closed. And I'm going to draw a line in between. And then that interval notation is going to start at -4, square bracket, and end at 2. Also square bracket. Questions on that? Are there any others on this page we want to see you go over, have questions about? 2, 10. What would we do first in 10? Distribute the 2. This is the case where you could also divide everything by 2 first, because everything is divisible by 2. So you have options. 2x minus 12 is less than or equal to 4. Also notice that I only distributed inside. I didn't multiply everything by 2, which you could do, but that would be a different scenario. Okay, what would be our next step? Add 12 to everything. We have 10 is less than 2x, which is less than or equal to 16. 5 is less than x, which is less than or equal to 8. So those would be open at 5, closed at 8, so the line's going to be a little short. That would be parenthesis 5 to 8 with a square bracket. Now, I do want to point out one thing. So I'm going to make up a problem. This is not this problem. This is a completely separate one. So let's say I had something like this. What I just had, but in the middle it was negative. So 10 is less than -2x, which is less than or equal to 2. And then I divided everything by -2. The signs are all going to flip. So this will become -5 is greater than x, which is greater than or equal to -8. However, the and inequalities always need to be less than or equal to, so I'm gonna take the whole thing and flip it. So that I start with the smaller number, -8. Make sure the inequality is pointing to or away from the same number, so it's pointing towards the -8. X, this is pointing towards the x, and then -5, and that would be that final answer of the made up problem I did. Okay, so for and, it always needs to be less than or equal to, even if the sign changes. Anyone have any questions in general about the and inequalities?
on-
It'll, for and, why did I flip it here? Because and inequalities always need to be less than or equal to. It couldn't be this. I do want to show you how to check yourself, so this is to check yourself, not to put questions in and get answers from. But in Desmos, you check yourself. If I'm looking at number 9, this is for the and, you have to separate it, so take the first part, -1 is less than 2/3 x plus 1. Then take the second part, the middle of that, 2/3 x. Plus 1 is less than or equal to 5. And then on that, I have one more. You'll see the first part starts here and keeps going to the right. And the second part ends here and keeps going to the left. But I don't care about just the blue or just the green. I want to know where do they overlap. So that would tell me this is where it starts, this is where it ends. We'll talk about the difference in the lines next class. But that would help you see for your ors. Sorry, for your ands. And then for your or inequalities, if I put in number 4, you have to do this separately. 7x minus 14 is greater than 0 and 4x plus. So on this, I can clearly see that this one is going just to the left, this one is going just to the right, and that would be where my graph is. And I could look at those two numbers to figure that out as well. Questions on how you could check yourself in Desmos? Okay. So if you didn't already do the multi-step inequalities that is due tomorrow, you'd be working on that. Or working on this delta math, the compound inequalities, which is also due tomorrow. Or you could be finishing your tests. Or working on other missing delta math. That's what we're doing right now. So everyone is working on something. Let us know if you need our help.